All right, here we're going to be learning about transformations. So we're going to be talking about two different kinds of transformations here, translations and reflections. So in geometry, a transformation is basically just changing a shape in some way. We're either going to be changing the size, the location, or the orientation. So changing the size comes with a dilation. It's either going to get bigger or smaller. We're actually not going to talk about those this year. Changing the location just means it's moving around somewhere on the coordinate plane. And then changing the orientation, I guess I could say you're changing like the direction of the shape. You're either rotating it or you're flipping it. You're just changing what it looks like on the coordinate plane. You're not changing the shape, you're not changing the size at all. It's just moving around and it's going to be like pointed in a different direction. So we'll see that with a reflection. That's going to flip the shape. A translation does not change the orientation, it just changes the location. It's just going to slide around. You're going to start out with an original shape, which is going to be called the pre-image. And we move to a new shape, that's called the image. So we start out with the pre-image, and we move to the image, that's the new shape. The way we indicate that is with these little apostrophes on the new shape. So we start out with A, B, and C. Those change to A prime, B prime, and C prime. When you add that little apostrophe, you just call it that letter and then the word prime. That's indicating that that's the new shape. All right, let's get into translation. So a translation, like I said, is a slide from one location to another. Doesn't change the orientation, doesn't change the shape at all. It's just going to slide it. So these are instructions on how to perform a translation, which looks complicated at first, but it's really simple. The x, we know the x-axis moves from left to right. So when I say x minus 8, that's instructions on how to move along the x-axis. It's saying we're going to take the original points and slide them that direction. When I say x minus 8, that's telling me that I'm going to take my x-coordinate and slide it 8 to the left. If it was a plus, that means I would go to the right. My positive numbers on the x-axis are that way, negative is that way. It's getting smaller going that way. So when I say x minus 8, that means I'm going to the left with each of these points. The y-axis is this one. That's going up and down. So these are instructions on how to move along the y-axis. Y plus 4 is saying I'm going to go up 4 with each of my points. So the first part tells you move left or right. The second part moves up and down. If that were a negative, we would go down. Since it's a plus 4, we're going to go up. So we're going to take each of these 2 points and move them by those instructions. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 to the left, and then 1, 2, 3, 4 up. I don't actually want to mark each of those. I'm going to erase that. That's where it's going to end up. It moved 8 to the left, 4 up. That's my new point, so I mark that with the apostrophe and say that that is point P prime. So the coordinates there are -5, +4. I'm going to do the exact same thing with Q. It goes 1, 2, 3, 4, 5, 6, 7, 8 to the left, 1, 2, 3, 4 up. That ends up at -2, -2. That's my new position for Q prime, -2. That's supposed to be a -2, -2. And you can see the line doesn't change at all. It's the exact same line. It just shifted 8 to the left and 4 up. Same kind of thing on this next one. We're looking at this triangle EFG, and we're going to take each of those points and move them based on those instructions. Again, the X tells you move left or right. The Y tells you move up or down. If it's a plus, that means you're adding to the X value. That means we're moving to the right. And for the Y value, if that's a minus, that means I'm going down. So I'm going to take each of those points and move 6 to the right and 1 down. 1, 2, 3, 4, 5, 6. And down 1, that's a new spot for E. F 1, 2, 3, 4, 5, 6 to the right, down 1, that's a new spot for F. Same thing for G, 6 to the right, 1, 2, 3, 4, 5, 6, and then down 1 spot. That's where G ends up. All right, so E ended up at -2, -2, F ended up at 6, 1, and G is at 3, -9. I want to point one thing out here. You actually don't need the picture to do this. When I say x plus 6, I'm actually saying add 6 to the x value. So let's look at F. F starts out, the original point is at 0, 2. If I add 6 to that x value, that becomes 6. If I subtract 1 from the y value, that becomes 1. I'm literally doing that with those coordinates. I'm adding 6 to the x, subtracting 1 from the y, or on the graph, that means I'm moving 6 to the right and 1 spot down. It's really just different ways of looking at that same information. All right, I'm going to do one of these at the bottom with you, and then I'm going to hope that you could do the rest on your own. Actually, I do want to talk about just horizontal versus vertical. Horizontal is left to right. So when I say horizontally -3, that's the same thing as saying x minus 3. And if I say vertically, that means I'm going up and down, and it's a positive number, so that means I'm saying y plus 4. So you're going to the left 3 and up 4. I really want to talk about number 3 because that looks a little bit different from the other examples. So you can see nothing is happening to that x. We're not adding anything there, which means we're not moving left or right at all. So I'm going to translate point E. I'm going to start here, and I'm going to translate it by that rule. Saying my x stays the same means I'm not going left or right at all. I'm just going to do this part of it. Y plus 5 means I'm going to go up 5. So I'm going to go 1, 2, 3, 4, 5 up. E should end up there. That's at 3, 1. All right, I think you could try the other 4 here on your own. I'm going to go on to the next page for these 4 we try questions because they're asked in a little bit different way. It's not just straightforward doing the transformation. Some of these are working backwards, so I just want to go over those. Actually, I kind of already talked about number 1. We're going to write the coordinates of the point 4, 3. That's our original point after each of these transformations. When I say x minus 4, I'm literally saying you take the x value, the original x value of 4, and you subtract 4 from that. Well, 4 minus 4 is 0. When I say y minus 3, I'm saying you take that y value and you subtract 3 from it. 3 minus 3 also equals 0. So if I translate this point by this rule, that ends up at 0, 0. For letter B, I'm going to do that same thing. My original point is 4, 3. This is saying don't touch the x value. We're not adding anything. We're not subtracting anything. It's going to stay the same, so it stays at 4. And y plus 2 is just saying add 2 to that. Add 2. That becomes 5. So when you're dealing with the coordinates, you really just do exactly what it says. You either add or subtract to both the x and the y. All right, on number 2, the coordinates of the square SQRE were translated on the coordinate plane. So it's saying we're going to take these points, SQRE, and we're translating them. They're all getting moved by the same amount to their new points. So the translation is consistent throughout each of these. So the same thing is happening to all of these coordinates. So I want to think about how to write this rule. So let's just pick, I think the bottom one's the easiest to look at. It's going to be the same for all of them. But looking at this coordinate, going to that coordinate, going from 2 to 0. I want to think about what I added or subtracted there. Well, it went from 2 to 0, so I just subtracted 2. That's my rule for the x's, x minus 2. I took the x value, and I subtracted 2. For the y, going from 5 up to 8, that's adding 3. So I took each of my y values, and I added 3. And you can see that's true for all of them. 4 to 7, 1 to 4, 2 to 5. You're doing the same thing each time. You're subtracting 2 from the x and adding 3 to the y. Number 3 is kind of the same, except it's a picture. Still trying to come up with a rule, but now I kind of just have to count instead of adding and subtracting. I mean, I'm still adding and subtracting, but I just want to think about it on the graph, going from D to D prime. I'm going 1, 2, 3, 4, 5, 6 to the left. 6 to the left. I'm subtracting 6 from each of those x values, so I'm going to write x minus 6. And then from here, I'm going up 1, 2, 3. I'm adding 3 to each y value. This is saying you went left 6 and up 3. Didn't matter which coordinates you use. You always just want to use the same one. So if I chose A, you got to go from A to A prime, not from like A to B prime. You just match up those corresponding points. All right, the last one for translations. Rectangle spat was translated, so we're showing this changed into a new rectangle here by some sort of translation. So we want to think about what happened for the original points to change into these new points. For negative 3, 2 to change into negative 1, 1. So how do I go from negative 3 to negative 1? What's really happening there? Well, from negative 3 up to negative 1, that's increasing by 2. So that's saying I'm taking my x value and I'm adding 2 to it. The y value is going from 2 to 1. That's just going down by 1. So I'm taking 1 away from that y value, so it's y minus 1. So I'm going to apply that to p. I'm adding 2 to the x. That becomes 3. And I'm taking 1 away from the y. That becomes 1. For a, I'm working backwards. So I'm given a prime. I'm given the new point. And I want to think about how did I get there? So I added 2 to the x to get to 3. That must have started out as 1, because 1 plus 2 is 3. To get down to negative 2, I took away 1. It must have started at negative 1, because negative 1 minus 1 gets us down to negative 2. All right, that is it for translations. I'm going to keep going on to reflections. You may want to pause now and do the translations, or I guess you can keep going with the reflection notes and then come back to the practice. So a reflection is a flipped image. You can also say it's a mirror image. It looks exactly the same. It's just going to be on the opposite side of a line that we're flipping over. So here we're talking about reflecting P over the x-axis. So the first thing I would always do is highlight what we're going to flip over. It's this line. That's our x-axis. So P is going to reflect over that line. It's going to appear exactly the same distance away from that line, just on the opposite side. So right now, P is 1, 2, 3, 4 above the x-axis. It's going to be 4 below the x-axis after the reflection. That is where P prime ends up. So you count how far is it away from the line that we're flipping over. In this case, that's the x-axis. And then put it on the opposite side that same distance away. It was 4 away to start. It's still going to end up 4 away just on the other side. So P prime ended up at 5, negative 4. On number 2, I'm going to reflect this over the y-axis. So that means it's going to jump over that line. So I want to count how far is it away from that line right now. It's 1, 2, 3, 4, 5 away. It's still going to be 5 away, just on the opposite side. 1, 2, 3, 4, 5 away on the other side. That's going to be at negative 5, positive 4. Kind of missed a little bit there. But that's supposed to be at negative 5, positive 4. Take the original point, count how far you need to go to the line we're flipping over, and then count that same distance in the opposite direction. On these next two, it's going to be a shape rather than just one point, but it's the exact same thought. We're taking both of these points, counting how far away they are from this line that we're flipping over, the y-axis, and then we're going to put them on the opposite side, that same distance. So right now, P is 3 to the right. It's going to end up 3 to the left. So P prime is at negative 3, 0. Q right now is 6 away. That's 6. So it's going to end up 6 away on the opposite side at -6, -6. This is what I mean by a change in orientation. So originally, this line was slanty that way. Now it's slanty that way. It's not really changing the shape. It doesn't change the size at all. It just changes the direction of the shape. It's really just flipped over. Last one, we're going to reflect this whole triangle over the y-axis. That's my y-axis. So you're going to notice that F is actually already on that line. So F doesn't move at all. Actually, it's going to stay exactly right there. F prime and F are going to be at the same spot. They are both at 0, 2. E right now is at -8. You can see that the x-coordinate is -8. It's going to jump to +8. It's 8 away from that mirror line, or that reflection line, or the y-axis. It's going to still be 8 away, just on the opposite side. So it ends up at 8, -1. Now G is just 1, 2, 3 away. It's going to be 3 away on the other side. So G ends up at 3, -8. Again, you can see the shape didn't really change, just flipped over that line. It changes in orientation, does not change in size. It also changes location. I think you can do the rest of these on your own. Actually, maybe I'll do one from the back. So this is where we're combining two different transformations. So I'm going to look at number 1 here. We're going to graph the image after the transformation and then record the coordinates below the graph. So I'm going to take this rectangle and reflect it over the y-axis, and then I'm going to reflect it over the x-axis. So I'm just going to mark my points after I reflect it over the y-axis. So I'm jumping over this line. Try that again. Jumping over that line. So D right now is 1 away. It's going to be 1 away on the other side. C is 1, 2, 3, 4 away. It's still going to be 4 away, just on the other side. A and B, kind of the same. That's the reflection over the y-axis. Now I'm going to take that new shape and reflect over the x-axis. So now I'm going to reflect that shape, that new one, over this line. So I'm going to count. That's 2 away. That's 2 away. There's still going to be 2 away. Actually, I might want to mark these. That's where D ended up. That's where C ended up. That's where B ended up. That's where A ended up. D is now 2 above the x-axis, so that's really the final location for D prime. C ended up here, again 2 away from the x-axis. B is 4 below, A is 4 below, they're just going to end up 4 above. So those are the final locations for A, B, C, and D prime. It jumped over the y-axis. Then it jumps over the x-axis. So A ended up at -1, 4. B ended up at -4, 4. C ended up at -4, 2. And D ended up at -1, 2. All right. Hopefully that helps. I know that was a long time of me talking, but I feel like once you get this, it's pretty straightforward. If you need help, ask for help.